What we're talking about, and you don't need to write this on your piece of paper because it's on your formula sheet. We're going to be talking about all the ways that I can mix and match change in momentum impulse, mass times change in velocity, which is mv final minus mv initial disguise, force times time. You don't need to write that down. It's on your formula sheet. I'm putting the vector symbols because, Alexia, today we're going to be needing to pay attention to direction sometimes. I called this multi-step momentum questions. We're going to get into some fairly long questions where we're not going to panic. We're going to ask, okay, what else can I find? What else can I find? What else can I find? But first, Owen, we're going to start with example 1. Example 1 says, a force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. Owen, what does A want me to find? Keep reading. Magnitude just means size. Don't ever tell me it wants me to find the magnitude. That's saying it wants me to find the answer. Keep reading. The magnitude of what? Change in momentum. I'm going to write this down. Look at your change in momentum equation on your formula sheet, Owen. Look at what they gave you in this question. Which version am I going to use? And don't overcomplicate it. You're looking confused. There's no confusion. Owen, look up. What's this right here? What are the units next to that 8? So what's it a measure of? Starts with an F. And then an O. And then an O. Okay. Yes? What? You just said it. What's Newton's a measure of? Don't overcomplicate it. What's Newton's a measure of, my friend? Force. Yes? Okay. Keep reading. What's this 10? What are the units next to it? What do we measure in seconds as a what? So you're saying this is a force? You're saying this is a time? Again, I ask you, which version of the change in momentum equation am I going to use? I'll give you a hint. I don't think it's this one. Okay, don't overcomplicate it. Look at the data that they gave you. I totally agree with you, my friend. Force times time. Owen, what's the force in newtons? What's the time in seconds? You might even be able to do this in your head, Owen. 80 times 10. Okay. The change in momentum is 80. Now, Maddie, if you decided to say 80 kilogram meters per second, I give you full credit because change in momentum is momentum. Because I went force times time, I would probably write the units as Newton seconds, which also works for momentum. If you're wondering why, Ryder, in my answer keys, how can we use Newton seconds? How can we use kilogram meters per second? It's probably the numbers that I used to get the answer subconsciously. Those are the units in my brain. I just wrote those. Okay, so if you're wondering why I flip-flop, oh, I used force and time, so I wrote Newton seconds. Oh, I used a mass and a velocity. I used kilogram meters per second. Owen, is that okay? Good. So the change in momentum is what, Shahab? How big? And I just said magnitude because I didn't give you a direction like north, south, east, or west. So just got the size. Okay. What's the magnitude of the object's impulse? Too slow. What's the magnitude of the object's impulse? Why is it 80? Because impulse and change in momentum are the same thing. All this question part B was asking is, have you clued in that another word for change in momentum is impulse? Impulse is written, change in momentum, it's 80 Newton seconds. Okay. Div, what's C asking me to find? What's my symbol for change in? Is it a triangle? We don't call it that. It's asking me to find that. Which equation has a delta V in it? You know what? I think this one here on your formula sheet. What did we just find? You know what? I think we can use our answer from B. I would probably write this down. And I would get the delta V by itself. How would I get the delta V by itself? One line. The change in velocity is going to be 80 divided by, was the mass 4? Heck, you might even be able to do that in your head. Units, it's a velocity. Now, this doesn't mean that VF is 20. This is the change in velocity. Alexia, that means if VI was 1, VF is 21. That's it. change of 20. If VI was 10, VF is 30. If VI was 51, VF is 71. That's a change of 20. Okay? So far, so good. Nate, what's D want me to find? Well, let's read it together. It says, if the final velocity was 12 meters per second north, what does it want me to find? So I got a VF. It wants a VI. What did I find in part C? Because when in doubt, look at the previous question. You might use the previous answer to find the next answer, right? What did they ask us to find in part C? In part C, they did not ask me to find VI. Sorry? They did not ask me to find velocity. The change in velocity, that's hugely important. What did they ask me to find in part C? Say it again. From your formula sheet, top left corner, what's change in anything? So it seems to me I can write this. The change in velocity, which I know, is going to be the final velocity minus the initial velocity. Because that's what change in anything is. You okay with that, Owen? Nate, what are they asking me to find? Get the VI by itself. What's right in front of the VI that I don't like? Swappy dance. I'm going to plus this to here, and I'm going to minus this to here. When I do that, I'll get VI equals VF minus delta V. Right? What's VF? They told me. Minus, what's delta V? They figured it out. Heck, you might be able to do this in your head or use a calculator. I don't care. Okay, negative 8 meters per second. Now, I should have added in brackets magnitude and direction. What's the negative telling me as a direction? Well, Nate, you said VF was 12. What you really implied was positive 12. You decided which direction is positive. So what would negative? If they'd asked for a direction, this is 8 meters per second at south. In this situation, you were going backwards, south at 8 meters per second. The change in velocity of 20 meters per second north made you end up at 12 meters per second north with your final velocity. Is that okay, Banner? Okay. I'm going to pause and I'm going to say, I hope you really haven't learned anything new so far. It's just been clarifying some stuff. Let's keep going. A snow scooter has a mass of 350 kilograms. A constant force acts on it for 60 seconds. The snow scooter's initial velocity is 2.5 meters per second. Its final velocity is 18. Alexia, what's A asking me to find? Well, I'm going to write delta P, and then I'm going to ask, okay, which version am I going to use? So I see a mass. There is one of them that has an M in it. Ooh, I see a time. Do I see a force in newtons in this question? No, in fact, what's part B asking me to find? Okay, so I don't think I'm going to use this version. What's changed in anything? Read the question. Did they give you a V final? Did they give you a V initial? Ding, ding. Okay, now I know which version. See how I put that together? I'm going to use this version. Don't write this down. I'm going to think that, except what did you tell me change in anything was? So I'm going to write MV final minus MV initial. Read the question carefully, Alexia, all of you. Is there any indication of a change in direction? Is there any indication that I need to let one way be positive and one way be negative? In other words, do you see a north and a south? Do you see an east and a west? Okay, then we're good. What's the mass? I've scrolled down. It was 3 something. 350? What's V final? 18? Minus 350. What was V initial? What is the impulse? What is the change in momentum of this? I have no idea. This might work out evenly because of that 350, that zero. Does it? What'd you get, Alexia? Yeah, I know you're typing. When you're done. Sorry, I should have said when you're done, tell me what you get. Get 54.25? Okay. 54.25. Now, this is a change in momentum. You could write Newton seconds like we did in the previous question, but since we use mass times velocity to find it, probably in my answer key, I would have just written mass kilograms meters per second, but I would take either. They didn't give me enough information to do a north, south, east, or west, but that's okay. What's B want me to find? Okay, everybody put your pencils down, look up, don't write this down. Look up, don't write this down. You could, and I will give you full marks, full credit, do this. F equals what? You could say, okay, they want me to find a force. Do I know the acceleration in meters per second squared? No. Okay, don't write this down. And so you could say, okay, A equals question mark. They gave me a VF. They gave me a VI. Oh, did they give me a time? I think you have to read it. What was the time? They gave me a time. 60. You could say, hey, I'm looking for an equation. It's got an A, a VF, a VI, and a T. There is one. You could say, that's going to be VF equals VI plus AT. You could then get the A by itself. Oh, and you could go A equals VF minus VI over T. You could crunch the numbers, you could get an answer, and then you could walk that answer over to there. And if that's your comfort zone, I'm fine with that. But we can use a shortcut. What did we find in part A, Alexia? Okay. Adam, you with me? Good. What did we find in part A? The change in momentum, the impulse. Is there a version of that change in momentum equation on your formula sheet that has a force in it, that has an F in it? I think it says this. So this is what you can all write down. Impulse, I'll do it in black, is that. Yes? I didn't bother running the delta, but yes? Get the F by itself. How to move the T over? Have I got the F by itself? Say it. One line. Not four line, one line. And so what I'm trying to say to you, Maddie, is the impulse equation is also a nice shortcut. You can survive without it using kinematics and F equals what? MA. And if you're more comfortable with that, Owen, I'll give you full credit. But shortcut. Because, let's keep going. Scroll down a little bit. F equals, what was the impulse? Was it 54.25, Alexia? Is that what it was? And then what was the time? 60. What's the force? It's going to be just under 100, something in the 90s, I think, but I can't do much more than that. Or I could be totally wrong. And of course, you cleverly used your answer button divided by 60 instead of retyping the 50. Probably still remember the old answer. Sorry? 90.4. Anybody else? Units, it's a force. Newtons. If they had asked for a direction, it would be in the same direction of the impulse, but they would need to give me more information. And so I'm going to argue here, Nate, the impulse equation, nice shortcut. One line, 5 lines. Same answer if you did it the long way. So I'm not going to erase that. I'm just going to say I wouldn't do it that way. I wouldn't do it that way, but you can. Next page. I like example 3. Also because it's rocket science, so my little math nerd heart goes pitter-pat. A rocket of mass that, starting from rest, you know what? I probably underlined from rest. What does from rest tell me, Marcus? I'd probably maybe just say, okay, VI is 0, or I'd certainly put a pin in that in my brain. Is acted upon by a net force of that for 120 seconds. Marcus, what does this want me to find? Example 3 is not asking me to find a change in momentum. Your hint is read the last sentence of the question and you'll figure it out. I almost said to Marcus, it's not rocket science, but it is rocket science this time. So I can't use it. What is it? VF. Okay. Don't write this down. Don't write this down. But you could go VF equals question mark. You could say VI equals 0. You could say T equals 120. You could say I need acceleration. How can I figure? And you can find the acceleration by going F equals what MA, and then using whoever's Banner's theorem. All doable. It's about 4 lines, 3 lines, all doable. And if you do it that way, will I give you full marks, Marcus, if you get the right answer? Say yes. But there's a shortcut. Do you notice, Marcus, they gave me both a force and a time? I can use the impulse equation. This first line we're only going to write once, but this is what I'm going to think to myself. Can you all write down impulse equals impulse, which I realize is stupid obvious, Ryder, but what I'm saying is that is always true, and now I'm going to write this impulse equation in 2 different ways. I'm going to write it as force times time, and I'm going to write it as mv final minus mv initial. That is impulse equals impulse. It has to be correct. Marcus, what did you say they're asking me to find? Put a dot above it. Now, Ryder, in this case, VI is 0, which means don't write this down, don't write this down, don't write this down, which means this whole term is going to vanish, but I'm going to pretend it doesn't as though it was a more complicated question, and I'm going to show you, Marcus, we can get the VF by itself. How would I get the VF by itself? Reverse bed mass, formula manipulation. How would you get the VF by itself? Plus this over, I'll change colors. Then what? And again, Marcus, I say 1 line, not 4 lines. Yeah, because now we're just going to plug it in. F equals 2.3 times 10 to the 4th time 120. Oh, what is VI? So now I'll cross out this whole term because that's just going to vanish. All over m 2.6 times 10 to the 4th. What's the final velocity going to be? You're going to have to use your scientific notation button. Remember, I said I was sneaking as much review in as I could, so I'm reminding you where your scientific notation button is, which I think was the very first lesson that we did. Is this a fraction? Yes. Is there more than one thing on the top? Yeah. Use your fraction button or brackets around the top. I think you're going to get, I'm doing some very rough math in my head, you're going to get a little less than 120, probably 100, something in the hundreds or hundreds and tens, but I can't be more than that. Marcus, what'd you get? 106, even or decimal? Probably decimals, yes? Yeah, I didn't think this was going to work out even. 106 units, Marcus. The impulse equation div, it's a nice shortcut if you wrap your brain around. I'm lazy but organized, but the emphasis is sometimes on lazy. I like the shortcut, but example 4, a car of mass 1,600 kilograms moves at 32 meters per second. What braking force is needed to bring the car to a halt in 1.6 seconds? Adam, what's this question asking me to find? F equals what? What? You could go F equals ma, and then you would say, I don't know the acceleration. There's enough that you could find it. But did they give me both a force and a time? Well, they didn't give me a force and a time, but they gave me a final velocity and initial velocity. Adam, what's the final velocity as a number exactly? I'm going to try impulse equals impulse. I'm going to try going like this. mv final minus mv initial equals force times time. Because what did you say they're asking me to find? Get the F by itself. One line. Oh, and what did you say V final was? Because it says comes to a halt. This whole term is going to vanish. I'm going to get this. The force is going to be negative m 1,600. V initial 32 divided by 1.6. This is going to work out evenly, I think. 3,200 or 32,000? Negative. It's going to be negative. 32,000 or 3,200? I can't remember. Do the zeros. Negative 32,000? Units, Adam. It's a force. What's the negative telling you? If the car is going forwards, the force must be. If the car was traveling north, the force must be. If the car was traveling west, the force must be east. Which makes sense. To slow a car down, you have to apply a force in the opposite direction that it's traveling. Again, here the impulse equation was a nice shortcut. The impulse equation isn't always a nice shortcut. And there's kind of a science and kind of an art, Maddie, to figuring out when it is. Maddie, I saved this one just for you. This is a very tough question. Example 5. This is probably tougher than I would throw at you on a test, maybe even tougher than I would throw at you on a quiz. I'd be comfortable in the homework because I want the homework to be tougher than the test. Read along with me, Maddie. It says this. A 2.5 kilogram rock falls from the top of a 40-meter high building and it strikes the ground below. What is the force? Magnitude and direction. Let's make sure I do a direction of the ground acting on the rock if it comes to a stop in 0.35 seconds. Okay. Don't write this down. I'll write some stuff down. This is my brain thinking. I noticed they want me to find a force. They gave me a time. I thought maybe I can go. Don't write this down. MV final minus MV initial equals force times time. That was my first thought. And I said, okay, let's do a quick check. Do I know the mass? Do I know the final velocity comes to a stop? Do I know the initial velocity when it hits the ground? I said to myself, I don't think this is going to be a good shortcut because I didn't have everything I needed. So instead, I said to myself, what are they asking me to find? F equals what? I pivoted to, okay, write this down, please, folks. Do I know M? Do I know A? Isn't it negative 9.8? No, that's while it's falling. That's not while the ground is bringing it to a stop. In fact, let's make some predictions, okay? When the rock hits the ground, be stupid obvious, which way is it traveling? When it hits the ground, does it speed up or slow down after it hits the ground? Be stupid obvious. So if it's moving down, but slowing down, what direction is the acceleration? It starts with letter U. What direction is the force? Starts with letter U. So when it says magnitude and direction, I better get up. However, whichever way I let be positive, whichever way I let be negative, it better match up. Okay. A equals question mark. And this is A from the ground, not from gravity. It's not negative 9.8. Alrighty. Well, this time That's how long it took the ground to bring it to a stop. It's not how long it fell for. That's how long the ground acted upon it. So I can use that time here. And you told me VF was what? Because it brings it to a stop. What do I need to find A? So they gave, don't write this down, they gave me that. Is that how far it traveled after it hit the ground? Not going to help me. Might help me later on. What do I need to find A? I need this. Now, what is that? That's how fast it was traveling right when the ground started to slow it down. You know what else that is? That's how fast it was traveling when it hit the ground. That's VF from free fall is going to be VI for ground. Does that make sense? So I'm going to go and I'm going to draw a little picture here. I'll change colors. Now I'm going to go to free fall. So here's the building. It says it was 40 meters. I'd like to find VF, which is going to be VI once it hits the ground, which is going to give me A, which is going to give me M. As I said, this is a multi-step question. So Laura, going to pivot to you. Oh, now I know the acceleration and free fall. You've probably memorized this out of laziness. Good. Maddie, back to you. What's the displacement? Don't say 40. Negative 40. What else do I know? If it fell off of the building, what can we probably assume? I think we can assume that. Laura, back to you. I'm looking for an equation that's got a VF, an A, a D, and a VI in it. There is one. Why'd you waste my time? Okay, we could go straight to VF squared equals 2AD. How does one get rid of a squared? So it's going to be the square root of 2 times negative 9.8 times negative 40. This might work out evenly. Yeah, I think I'm getting all perfect squares. I think this will work out evenly. Maddie, what'd you get? That can't be it. Ooh, this is that, again, weird situation. Ryder, we took the square root. Your calculator assumed you wanted the positive value. I know the rock's not traveling up, though. Which way is the rock traveling? Down. Oh, and now you've just decided down is negative. We kind of did with the negative 9.8, which means if the force is up, it better be positive when we're done. Okay, let's continue. So we go like this. Now that's V final when we hit the ground, which is also V initial when we start coming to a stop. Laura, I'm looking for an equation that's got an A, a T, a VF, and a VI in it. There is one. Get the A by itself. The VF would drop down like a domino. I'll cross it out as a 0 in a second, but I'll keep it there temporarily. Minus VI all over T. Yeah, that's a 0. So it's going to be negative 28 all over 0.35. Maddie, what's a negative? What direction would a positive be? Starts with letter U. What direction did you say we were accelerating when we thought this? Okay, I'm probably doing this right. There's no way I'm fluking into the direction. Now I'm getting a little adrenaline rush, heart's beating. I'm going to get this. This might work out evenly too. What do you get for the acceleration? I think it'll work out nice. No? What? Positive 80, yes? Now I walk over here. F equals M. I've scrolled down. What was the mass? What was A? Positive 80. I can do this in my head. It's going to be 160 plus 40. Is it 200 even, I think? 200 newtons. That's the magnitude. Direction. Yep. Alexia, I don't know if you remember, the title of this lesson was Multi-Step Momentum Questions. This is multi-step, but I would also say, did you learn anything new there? I kind of hope not. We've, I think, done all of that before. I just don't know if we've combined it in that many steps. And yeah, I made a value decision. I think it would be less writing to do F equals ma. If you're bored, you could try it using the impulse equation, and you'd find you end up doing pretty much the same stuff in different orders, but you do about the same amount of writing. So I went back to my comfort zone. Good yawn, Owen? Good. Were you yawning? No? Okay. I like example 6. I like example 6. I like example 6. Example 6 is a nice question. A ball moving at 4.65 meters per second east hits a wall. The wall exerts a force on the ball of 350 newtons to the west for 0.075 seconds. Find the final velocity, magnitude, and direction of the ball. Can anybody see why they or guess why they think I like this question, I like this question, I like this question? And I'll give you a hint. It's 2 words that start with a capital letter. What? Is there a change in direction in this question, Ryder? That means I'm going to have to let one way be something and one way be something. Can you fill in the something blanks, please? I'm going to have to let one way be and one way be. Ryder, what do you want to let be positive? Pick. I don't care. You're going to let east be positive? You could let west be positive and you'll still get the correct answer, but you said east be positive. Finish this phrase. You've heard it from me before. Lazy but. I'm going to be organized but lazy. This is what I would recommend. First of all, I'm not writing out, I'm letting east be positive. Not a chance. I'll change colors so you can see what I'm doing. If you can change colors, go ahead. If not, that's okay. I'm going to put a big plus sign in front of the word east, and now anything that's east gets a positive in front of it. I read through the whole question. That's the only east. What am I going to put in front of the word west? And then anything that's west, so that's west. What about that 0.075 seconds? It's a trick question. What do you know about time? Time is a scalar. It has no direction, much like your future, right? So time, ignore. That's important because if you accidentally stuck an extra negative in there, you'd get negatives divided by negatives when you didn't want it, right? What does it want us to find? You could go VF equals VI plus AT. You could solve for A. But I noticed, did they give me a force and a time? Let's try the impulse equals impulse trick. Let's try seeing if we can go mv final minus mv initial equals force times time. You're good? Thank you. Face down, block D. People on YouTube are going to be going, what was that? I'll let them wonder. What are we trying to find? Get it by itself? Good. Plus that over, because it's reverse bed mass. You do your adding and subtracting first, then you do your multiplying and dividing. And in fact, dividing, yes? One line. And again, if I'm losing you or you're just not comfortable with this, fine, go VF equals VI plus AT, solve for A, pay careful attention to your positives and negatives, and then find VF. Let's see. I'm going to get VF equals negative 350, yes. Positive 0.075 scalar plus 4.2 mass scalar. Positive 4.65 divided by 4.2. And it did say magnitude and direction, so once I get an answer, I'll convert that to a direction as well. This might work out nice. I'm doing some quick math in my head. I don't think you're going to get a yucky decimal, but I might be wrong. Oh, is this a fraction? Yeah, fraction button. Or brackets around the top. Ryder, what'd you get? I knew it was going to work out nice because I could see a bunch of stuff canceling. Is that right? Is it negative 1.6? Yes. Okay. Negative 1.6 meters per second. Okay. 1.6 meters per second. Direction. How do you know? That's why you wrote that, so you didn't have to go lazy but organized. But emphasis here both on the lazy and the organized. Right? Yeah. By the way, I guess what that means is the ball came in, if that's east to your right and that's west, the ball came in east, hit the wall, and bounced off. Of course, the wall had to push it to the west to do that because it had to bring it to a stop, and it gave it so much force it even went backwards. Not as fast as it came in, so it lost some of its momentum in the turnaround. Is that all right? Example 7. A rifle accelerates 12 grams. Dueck. Do I do physics with grams? So again, I was trying to sneak in some unit conversion when I was doing the review, but also you're growing up in Canada, you're Canadians, you're going to become adult grocery shoppers. You should be able to go from grams to kilograms to grams to kilograms in your head. Kilograms, what's kilo and abbrev for? 10 to the what or what number? It's 10 to the, it's a kilo is 1,000. So how do I convert grams to kilograms? It's divide by 1,000. You can use your calculator or you can do it in your head. 12 grams, how many kilograms? Because we don't do physics with grams. 0.012 kg. Okay. From rest, you know what? I'd probably underline the phrase from rest to 250 meters per second. The rifle barrel is about 0.85 meters long. Cole, what's A asking me to find? So I'm definitely going to write that down. Am I going to use force times time or am I going to use m delta v? How do you know? They gave me it's actually because they gave me a final velocity and they gave me an, that's the key, because that gives me the delta v. They give me the mass no matter what. Okay, so I'm going to say it's m v final minus m v initial. And in fact, Cole, why can I do this? Yeah, yay. Now, they didn't specifically ask for a direction. Okay. 0.012 times 250. 3 or 30? It's going to be the first digit's going to be a 3. 3 even? I'll go 3.0 to show off because I did it in my head. Units. Yeah, and if you said Newton seconds, I'm fine, but since we used mass and velocity, these are the units that would pop into my head. If they asked for a direction for a rifle, I guess forwards, because if it's backwards, something's gone horribly wrong. Can we agree on that? Yes? Okay. All right. Let's keep going. What's B want me to find, Cole? I don't want to write anything. I'm going to do some in my head. I thought, can I use impulse? Can I go? Well, if I wanted to use impulse, don't write this down. It would be force times time equals 3. Did they give me the time in this question? Okay, so no matter what, I'd have to find the time. Or I could go, because they want me to find force, F equals what? Question is, what's going to be easier to find, A or T? I think A. I just did some really quick math in my head. So here, although it's not wrong to use the impulse equation, and it totally works, I would probably choose to say, you know what? I'm going to go F equals MA. And I'm going to say A equals question mark. Because what's VI? And what's VF? And what else did they give me that I can use to find A? By the way, from a VF and a VI and a D, you can find time as well. It's the equation with the brackets in it, which is a bit creepier to get the T by itself, which is why I'm probably going to be able to, because what's an equation that has an A, a VI, a VF, and a D in it? You didn't waste my time. Thank you. You said, Mr. Dueck, A equals, no, not A equals. You said VF squared equals 2AD. And now, Cole, let's get the A by itself. How do I move the 2 and the D over? Yeah. Do I need to square root here? No, because it's not an A squared. If I was trying to get the V by itself, sure. Here, A is going to be VF squared divided by 2D. It's going to be 250 squared divided by 2 times 0.85. Before we go to our calculator, Cole, are we expecting a big acceleration or a small acceleration for a bullet? Yeah, if you get a big number, don't panic. You're probably right. Okay? If you get 12, you're wrong. It's probably going to be in the thousands or tens of, in fact, probably going to be in the tens of thousands. What'd you get? 6,000. What's after the 7? So I'm going to write 36,800 meters per second squared. But what button am I going to use on my calculator rather than writing out all the decimals? What button am I going to use on my calculator when I walk over to here? Of course I am. F equals 0.012 times my answer button. That's what I'm going to do. Less writing, less chance of a typo, more accurate. What'd you get? Which isn't that big a force, which is actually correct. You don't need that big a force to get a small bullet going really fast. And it couldn't be that big a force because forces come in. Remember the elephant gun video that I showed you of the guys firing the really, really high-powered rifle where it was driving their shoulder back? You don't, because forces come in pairs, you don't want too big a force on the bullet. Otherwise, the human can't fire the gun because the shooter gets the same force as the shootee or whatever you call it. What did you say the answer was? Did they say magnitude and direction or just find the force? Okay. In the same direction as the bullet, forward. Right? So here's a situation where I could have used impulse and I made a value call. It was easier to go F equals ma, which it was. Almost done. Thanks for your patience, folks. Example 8 says, consider the diagram at the right for the next 3 questions. Let's look at this. Case A, this is the same car. It's coming in at 5 meters per second, hits the wall, and bounces off at 4 meters per second. Case B, same car, coming in at 5 meters per second, but this time it hits the wall and it stops. So it says, the diagram depicts the final and initial velocities of a car in 2 different collisions. Case A, the car rebounds. Case B, the car hits the wall, crumples, and stops. And just to make it easy, let's assume that time is the same in both collisions. So Arnica, we're not worried about the time. Here's the question. Number 1 says, in which case does the car experience the greatest momentum change? You know what? We're going to vote. How high you hold your hand up is how sure you are of the answer. So look at those 2 situations. And our options are case A, case B, both the same, or I need more information. Who says, Mr. Dueck, I think there's a bigger momentum change in case A? Duh, it's obviously case A. It's case A. I got 1. I got 2. Got 2. Case B, obviously, because the car came to a stop. Got 1, I got 2, I got 3, I got 4, I got 5, I got 6, I got 7, I got 8, I got 9, I got 10, I got 11. Both the same. Got 1. Need more information. Maddie, which one you voting with? Because I don't think I saw your hand come up. You going to go with A? Let's see if we can figure out the answer. So, do they have the same mass? Then what I'm interested in is the change in velocity in case A and the change in velocity in case B. What's the change in velocity here? Well, what's change in anything, Arnica? From your formula sheet, top left corner, first thing. Yeah, final. Okay. What's final minus initial? No. Is there a change in direction? Then I need to let one way be and one way be. So everybody put a big plus up. Everybody put a big plus sign there and a minus sign there. It's going to be -4 minus 5. Do you know what the change in velocity is here? -9. Do you know what the change in velocity is here? 0 minus 5, -5. Which one had a bigger change in magnitude? Which one had a larger magnitude change in velocity? Situation A or situation B? Which one had a bigger change in momentum? Situation A or situation B? A. Because the car didn't just come to a stop. It bounced backwards. That's a much larger change in momentum. Question number 2. In which case does the car experience the greatest impulse? Nick. Why? Because impulse is the same thing as? It's the same question. Number 2 is the same question as number 1, just phrased differently. Oh, number 3 says the impulse encountered by the 800 kilogram car has a magnitude of, well, impulse is mass times change in velocity, so it's going to be 800 times -9, which is what? Adam, what? Yeah, they said magnitude. You get -7,200, but they're just asking about the magnitude. Yeah, that car that bounced backwards experienced a much bigger change in momentum, a much bigger impulse than the car that just came to a stop, which, turn the page, leads to something important about car safety. So, having seen that, what type of collision is worse for a passenger? Let's assume the initial velocities and the time of impact are the same. What type of collision is worse? A head-on collision where the cars stick together? Or a head-on collision where the cars bounce apart? Yes. Why? You'll have a larger delta V, which means the change in momentum goes up. The impulse goes up, which means the force goes up. How do I know the force goes up and not the time? Because it said the time is the same in all the situations. Which means the acceleration goes up. And what have I told you does damage in car accidents? Not force, not velocity, but acceleration. Okay? Because we could have, on those barriers by the pit bridge, instead of putting water barrels that bring you to a stop, we could have put a big spring on there so you bounce off. Why would that be worse? Way bigger impulse, right? So, having said that, we're going to finish with this. It says the diagram below depicts the changes in velocity of a ball that undergoes a collision with the wall. Arnica, what do you notice in both situations? There is a change in, I'm looking for it that starts with letter D. So I need to let one way be and one way be. So let's do that right now. Do you want to have initial or final be positive? I don't care, pick. Positive, negative. Positive, negative. Lazy but organized. The first question it asks is, which has the bigger change in velocity? Let's just crunch it. What's the change in velocity for situation A? It's going to be -5 minus 10. Double check me, but I think that's -15. What's the change in velocity for situation B? That's going to be negative 28 minus 30, I think is negative 58. And you can see, Arnica, if you miss the change in direction, it's tempting to say, oh, no, 5 and 2, right? So which one has a bigger change in velocity, A or B? Everybody. Good. Which one is going to have a bigger acceleration? B, because it had a bigger change in velocity, and acceleration is change in velocity over time. Which one's going to have a bigger change in momentum or impulse? B. Which one's going to have a bigger, impulse, force times time. Same answer. Is that all right? Yeah. I have a video. I'll show you. Maybe we'll show it now. I'll play it by ear. What's your homework? I need to give you lots of practice on this. It's going to be easier to cross out questions than circle questions because I did give lots of practice. So for the homework, you can cross out number 15. I already crossed out number 16. You can cross out number 19. Put a star next to number 20. Number 20 is a much tougher question that I'll ask on the test. I don't mind doing that on the homework because I'd rather you find the test easier than the homework. So it says nasty. But this question has 3 curveballs. The first one is the 2 words that I underlined near the beginning. Banner, what are the 2 words that I underlined? That's time. What's time in seconds exactly? So if you want to, you can make a little note above there, t equals 60. That's your first hint. The other 2 curveballs, see if you can figure out. Otherwise, I'll give you hints. You can cross out number 23. So we've been talking about crumple zones. We've been talking about impulse. We said that if you can make time go up, F gets smaller, A gets smaller in a car crash. This is a cute little video that some kids from Britain made as their school project, and it's a pretty good explanation.
Hello and welcome to today's lecture from Brit University. Hi, I'm Nick.
And I'm Jane.
Today we're going to look at momentum and how we can use this to understand why we need crumple zones in our cars. Let's start off by looking at some theory on the whiteboard.
That's correct. Momentum is mass times velocity. We know that.
Let's remind ourselves that momentum is equal to mass times velocity. If our car weighs 1,000 kilograms and it is travelling at 25 meters per second, what is its momentum?
I'm pretty sure 25,000. I can do that math in my head.
That's right, you've got it. 25,000 kilograms meters per second. What happens when a car hits a wall? Because the car's velocity becomes 0, its momentum must change to 0 during the collision. We can use the change of momentum formula.
Delta P equals F delta T. There it is. They're just writing it out in English.
To allow us to find the force that acts on the driver during the collision. Rearranging the formula, we get force is equal to change of momentum divided by the time over which the collision ends.
With that.
Now we can use this formula to see how we can reduce the force on the driver.
If you can make time bigger, force gets smaller.
Because the change of momentum will be the same for any specific collision, if we increase the time, it will make the force smaller. Now we can put this theory into practice by looking at crumple zones in a real collision. Let's go over to our brave stunt driver, Ollie. Ollie, are you ready to go?
I think so.
Crumple zone.
Oh dear, I hope Ollie was okay after that second crash. Now let's go back to the whiteboard to see if we can work out the forces involved in those 2 collisions. So the car had a mass of 500 kilograms and a velocity of 10 meters per second. In the first collision, when the car had a crumple zone, the car and the wall were in contact for 1 second. So if we put those numbers into the formula, we can see we get a force of 5,000 newtons. Now let's look at the second collision. In this one, the car had no crumple zone. So the car had the same change of momentum, because it was still 500 kilograms, going at a velocity of 10 meters per second, but the contact time between the wall and the car was only 0.2 seconds. So if we put these numbers into the formula, this time we get a force that's much greater of 25,000 newtons, which is why poor old Ollie ended up being thrown out of his seat. You'll be pleased to know that Ollie has made a full recovery and will be ready to do some more experiments for us next week. That's all for this edition, so it's goodbye from me.
And goodbye from me.
Not a bad explanation. Folks, there's about 10 minutes left in class, 12 minutes left in class. The recording